Europium, symbol EU, atomic number 63, atomic mass 159.964, melting point 822.0 degrees Celsius, boiling point 1597.0 degrees Celsius, number of protons and electrons 63, number of neutrons 89, classification rare earth, color silver. Europium is a ductile metal with a hardness similar to that of lead. It crystallizes in a body-centered cubic lattice. Some properties of europium are strongly influenced by its half-filled electron shell. Europium has the second lowest melting point and the lowest density of all lantanides. Europium becomes a superconductor when it is cooled below 1.8 km and compressed to above 80 GPa. This is because europium is divalent in the metallic state and is converted into the trivalent state by the applied pressure. In the divalent state, the strong local magnetic moment suppresses the superconductivity, which is induced by eliminating this local moment. Europium is the most reactive rare earth. It rapidly oxidizes in air so that bulk oxidation of a centimeter-size sample occurs within several days. Its reactivity with water is comparable to that of calcium, and the reaction is 2Eu plus 6H2O is equals to 2Eu OH3 plus 3H2. Because of the high reactivity, samples of solid europium rarely have the shiny appearance of the fresh metal even when coated with a protective layer of mineral oil. Europium ignites in air at 150 to 180 degrees Celsius to form europium oxide. Europium dissolves readily in dilute sulfuric acid to form pale pink solution of the hydrated EU, which exists as a non-hydrate. Europium is produced by nuclear fission, but the fission product yields of europium isotopes are low near the top of the mass range for fission products. Like other lantanides, many isotopes, especially isotopes with odd mass numbers and neutron-poor isotopes like EU, have high cross-sections for neutron capture, often high enough to be neutron poisons. EU is the beta decay product of samarium-151, but since this has a long decay half-life and short mean time to neutron absorption, most SM instead ends up as SM. EU cannot be beta decay products because SM and SM are not radioactive, but EU is the only long-lived shielded nuclide other than CS to have a fission yield of more than 2.5 parts per million fissions. A larger amount of EU is produced by neutron activation of a significant portion of the non-radioactive EU. However, much of this is further converted to EU. EU has a fission yield of 330 parts per million for uranium-235 and thermal neutrons. Most of it is transmuted to non-radioactive and non-absorptive gadolinium-156 by the end of fuel burn up. Overall, europium is overshadowed by caesium-137 and strontium-90 as a radiation hazard, and by samarium and others as a neutron poison. Europium is not found in nature as a free element. Many minerals contain europium, with the most important sources being basnasite, monazite, xenotime, and ioparite.